EMxpert is a benchtop EMC and EMI scanner that enables PCB designers to effectively diagnose and solve EM problems in their own lab environment in real time. Problem frequencies are identified quickly and automatically, and can be mapped directly onto Gerber data to correlate RF currents with design features. EMxpert allows you to visualize the root causes of potential EMC and EMI problems in real time. You don't need to wait for chamber time to redesign and test by trial and error. You can rapidly diagnose even intermittent problems, which may not be detected at all when using automated single-style or handheld probes. EMxpert has helped to transform the design process for leading device manufacturers across a broad range of industries.
The EMxpert system consists of a patented scanner, a compact adapter, client software, a customer-supplied spectrum analyzer, and a customer workstation. The adapter connects to the spectrum analyzer through an external trigger and relays real-time scanning data from the patented scanner to your workstation. The patented scanner is an automatically switched array of 1,218 pairs of orthogonal antennas. The antenna pairs have effective off-axis coverage and are arranged in a grid with a spatial resolution of 7.5 millimeters.
The hardware is capable of scanning frequencies from 50 kHz to 4 GHz. A tiered license key system allows you to tailor the product to your needs, with a base license spanning 10 MHz to 1 GHz. Additional frequency range keys are available for purchase without additional hardware requirements. The first step in diagnosing an EMI issue is to isolate the problem frequencies. This is the board we will be scanning. In the EMxpert client software, we specify a frequency range for the scan. To ensure the fastest scan time, all of the probes outside of our board's area can be disabled. Problem frequencies can often be identified with only a handful of probes activated. If a known problem area existed, we could also choose to focus on that. EMxpert builds an initial peak list and then zooms into each of those peaks, rescanning them with tighter span and resolution bandwidth to determine the accurate peak frequency. We can zoom in on the spectral graph to see the exact amplitude and frequency values. Now that we've identified a problem frequency, we can find the exact location of the hotspots and RF current loops on the board with a spatial scan. We'll start by adding a spatial scan node to our spectral scan. The peaks that were automatically marked by the spectral scan are available for quick selection from the drop-down menu. The resulting scan shows the amplitude at each grid point for the frequency we selected, directly correlated to our board's design features. EMxpert's continuous spatial scan can capture any continuous or time-based event. If we turn on peak hold, the peak amplitude at each location is then replaced by each successive higher measurement. This is an excellent way to find the location of an intermittent signal at a single frequency. Real-time scanning also lets you instantly see the effects of design changes in your own lab. Adding a decoupling capacitor shows its effects on the EMI pattern. EMxpert provides fast, accurate, repeatable EMI scans that can drastically enhance the design process. You can save time by gathering all of the frequency, amplitude, and location information about a board with a minimum of setup. Just define a frequency range, and EMxpert will automatically run a spectral scan, as well as a set of spatial scans for all detected peaks. To reduce measurement time, sets of smaller frequency spans can be selected instead of a broad range. Time-based activity can also be captured by setting a number of continuous peak hold scans. In this example, we have set EMxpert to scan from 10 to 80 MHz. This will cover the fundamental and multiple harmonics. Once the scan is complete, we can quickly tab through the spatial results to check the distribution at each harmonic. A quick check of the fundamental and harmonic at 77 MHz shows there are two different problems to be solved. Fixing the current loop at the fundamental could still leave the problems at the harmonic unaddressed. EMxpert is a powerful visualization and diagnostic tool with real-time scanning, comprehensive comparison tools, and archiving capabilities. All scanned data can be archived in project files for later analysis. The design of EMxpert ensures that scans are highly repeatable, so you can return to scans from earlier in the development process to compare your current results. Design iterations can be analyzed with a variety of comparative views using a simple drag-and-drop interface. Spectral scans can be combined in overlay or comparison mode. Overlay mode displays the two datasets superimposed on each other, allowing you to visually inspect data for differences. Comparison mode subtracts one dataset from the other, displaying only the difference. These modes can be used to compare the spectra of a production device with a prototype device, for example. Spatial data can also be compared through subtraction, helping you find the position of a failure point in a production board after a spectral comparison has uncovered a frequency that is significantly different from the reference board. This is useful for repairing faulty boards or pinpointing manufacturing process problems. Limit lines can be added to spectral scans in the scripting module, which can be helpful in setting thresholds to control mutual interference in a multi-board design. Alternately, they can be used to compare results to previous design iterations when recycling a design for cost reduction or component obsolescence purposes. Note that limit lines cannot be used for regulatory compliance testing. After defining limit lines, you can generate a margin table to see the variations and which frequencies pass or fail. The EMxpert software can be freely distributed within your team, so you can share your project files with colleagues to get their input and compare results. The report generator exports test results to a Microsoft Word document for easy sharing with colleagues and management. When testing for emissions, the spatial scan provides a detailed map of emission sources and current loops in real time, whether testing for a single frequency or multiple frequencies using a composite spatial display. When mitigating immunity and susceptibility problems, EMxpert allows you to visualize how injected RF signals flow through a PCB and helps you relate these high-amplitude currents to sensitive structures. It also provides you with an archive of current flow across a wide frequency span for further analysis. EMxpert also helps you see when and how differential mode currents are coupling onto connectors and creating common mode radiation in cables or backplanes, enabling you to address the coupling at its source in real time. When working with switching mode power supplies, EMxpert allows you to quickly scan a board across a broad frequency range to characterize typical switch mode emissions. The scripting module's limit line feature provides a rapid picture of the level of a broad spectrum of noise, and any frequency can be spatially mapped to determine its source. EMxpert shows the effectiveness of filters and shielding, mapping near-field emissions generated by current flow on the surface of your board and helping you diagnose problems in real time. EMxpert's real-time scanning capabilities provide significant design advantages throughout the product lifecycle. Having immediate access to spectral and spatial analysis of your designs saves time and cost by reducing the need for costly board spins and test site visits. EMxpert also provides insights on the root cause of problems, allowing for more efficient and cost-effective solutions, project cost containment, and accelerated time to market. EMxpert. Rapidly diagnose and solve EM issues in your own lab environment in real time.